For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Okay, looks like we are live and not on mute this time. So here we are on late night with SFT. That first attempt was an epic fail, but here we are, and I promise you it's going to be worth it. This is going to be interactive. We got a couple videos, got a lot of papers to look over. It's going to be fun because tonight we are debunking Joshua Swamidass and Evograd. Title is Recombination Rates, the Scientific Adam and Eve. So the title being the Scientific Adam and Eve, I was simply pointing out in the failed stream that we're going to be covering some arguments from my book here. Let's see, for people who have it. The First Couple, Adam and Eve, Independent Origins. I'm glad to hear that people are enjoying it. What I'll do is I'm going to screen share when we get to those portion, and then therefore you can follow along in the PDF. I'm rocking the Devolution shirt. People seem to be liking it. Definitely check out that creationistclothing.com webpage. So I'm glad that everybody's made their way back to the chat. Yeah, it's going to be a lot of fun. I was also pointing out, probably by the end of the month, we will have, I know we've been discussing a lot on like out of Africa and the out of Babel model, for example, the biblical creation model. So we should have another interesting book out by the end of October. Time's flying by, so lots to look forward to. Good to see everybody in the chat. We got Jason, Dell. Thanks for sticking it out. I appreciate your patience. We started a little bit late today because I wanted to make sure I had a few papers and articles that I wanted to get through before we went live. It's been a busy couple of weeks. I've read through a ton of articles, papers. So yeah, this is going to be fun, guys. This is going to be fun. So why don't we, let's see. Why don't we start with the arguments that I've seen coming from the critic side when it comes to, so I'm going to screen share here. Okay, so what we've got here is Evograd. Now he is a critic, quite well known for criticizing. He's got a full rebuttal out there to Dr. Jensen's work. Now, I did a video recently addressing his argument, Joshua Swamidass's argument, for example, where they think the design diversity hypothesis fails. So here on the Peaceful Science webpage, he points out that, now this was in a previous video where I addressed his recombination rates argument. Okay, so he points out the only part of the video actually directed at me, so he goes to the timestamp. He says, he shows this post of mine, and we're going to go over exactly what that post says. So he notes that I acknowledge Africans have more recombination hotspots, but then completely ignores my point that this doesn't. So here's his point that he thinks is ignored. So I guess this would be his big argument. This doesn't seem to increase the overall recombination rate substantially, in brackets, as they claim, he says. He literally scrolls right over the post where I show the data and doesn't comment on it. So we have commented on it. We're going to comment on it a little bit more in detail tonight, and it's going to be fun. I've had a few streams going over their arguments from this website, from this blog, and the interactions that I've had with them. I'll put those videos for those who haven't seen them in the description box. And you can kind of see how they dodge a lot of the questions and a lot of the arguments. So logical, plausible, probable says, bro, never say web page ever again in relation to a website. All right. Advice taken, John. I know you're the expert when it comes to that. Good to see you, brother. Good to see you. I hope you didn't work too hard today. George Bond says, I'm still here setting up my new phone and listening. Awesome. Congrats on the new phone. Dell says, worth the wait. Yes, it's going to be fun. It's going to be fun. So the other argument, too, was from Joshua Swamidass, who says, But it raises several questions. And this was in regards to Dr. Robert Carter's interview and his answer specifically on the recombination rates that they believe is such a significant problem when it comes to our model, yet they never answer our questions regarding their many, many problems. So he says, as Evograd notes, reduced hotspots, and let me know in the chat if you can see these. He says, reduced hotspots doesn't imply reduced recombination. It should be easy, so using the same argument as Evograd, should be easy to test if they do by comparing recombination rates in Europeans versus Africans. Now, here's the funny one. Swamidass, who's apparently been, I guess, fighting against the young earth creation arguments for a while, he uses an argument here. He says, why do Africans and Europeans have different rates of degradation of PRDM9 hotspots? Now, here's the thing. In the exact video that they were commenting on, you'll find the answer to that question. So that either proves that he wasn't paying attention, or maybe he just commented before he watched the video. What we'll do, just to get people back into the chat too, because of the epic fail before, let's do a little, let's get a little interactive here. I'm going to replay Dr. Carter's answer to this issue, and you're going to see, pay close attention. You'll see how Dr. Carter answers that exact question in the video. But I want to point out too, because a lot of times they'll look to they'll say the mathematics fails, when in fact the mathematics fails for deep time evolution for their story. They'll say that, you know, population genetics, what we know about it is inconsistent with the independent origins model of all of us descending from Adam and Eve. They'll try and hide it in these sophisticated population genetics analyses and mathematics, of course. Well, we had Dr. Carter on last week, I guess it was, where he went over the mathematics and went over a number of papers and Mendel's accountant, and you can see that the math has been done and it's in complete consistency with young earth creation model. But here's the thing, okay? I want to point out before we show the video. Doki Doki Bible Club, good to see you, good to see you. So we're getting people back in the chat now. So here's the thing, standard population genetics principles, okay? Starting from the created heterozygosity hypothesis, okay? Adam and Eve are created, they got differences within themselves and across, okay? Now, here's the thing. We can actually explain all human variants today through the biblical model in just thousands of years, okay? All we need, and I've talked about this in great detail in prior videos, we need population fragmentation, random drift, and other mechanisms, of course. The Tower of Babel, let's say a few hundred years after the flood, what happened? God separated the people groups according to, well, we know that it was separated according to their Y chromosome, and these people groups would have remained isolated from each other, which would result in what? Regional differences. You would get people more, say, Asian, you know, those features. Australian, Aboriginal, African, European. Isolation in a short amount of time is all we need according to the out of Middle East, out of Babel model. Okay, so let's see here. We got people in the chat. I'm going to remove this picture and we are going to, that would be it in a nutshell, but we're going to get a little more deep here. So, okay, screen share, share audio. Boom. Okay. Make sure everybody can see. So we got a lot of papers we're going to cover on this as well. Okay. On the recombination. But let's go over Dr. Carter's answer real quick and pay close attention to Dr. Swamidass' second question. And see how the question is answered directly in the video. So we'll start it off with this, and then we're going to get right into it.
Started.
We can still use it if we want to.
Okay.
All right.
Well, when it comes to recombination, it's been asserted that the rates are too slow to account for the de novo creation of Adam and Eve around 6,000 years ago.
Lena in the chat so Lena says, so I think Lena Pow's already figured it out. Less hotspots does not mean reduced recombination. Yeah, we're gonna get right into that. But I just want you guys to pay close attention to Dr. Carter's answers and just see how I find it flabbergasting that Swamidass asked a question that was directly answered. See, a lot of times you got to do the homework for these evolutionists. And that's the problem. And that's why when you're spending a lot of time in those blogs, because they'll say, SFT, why don't you just spend all your life in those blogs? Well, when they're avoiding questions, when they're asking questions that have been answered 100 times, and most importantly, when Joshua Swamidass made that comment, I responded by saying, funny you asked those questions, because those questions were answered directly in the video that you were critiquing, and the comment was deleted. So it doesn't sound very fair to me. So it's pretty well a waste of time. But yeah, let's get right into it. Lena, good point. We're gonna hammer that actually. So some of it's going to be a little technical, but it's necessary given the nature of what and who we are refuting. So let's go.
An argument you false?
Well, what's the recombination rate? It depends on. We used to think it was random. It's not. It's controlled by a gene. The PRDM9 enzyme looks for a specific set of letters on the chromosome, grabs onto it, and recombines.
Oh, okay.
Africans have more of those sites than Europeans.
Oh, wow.
Whoa, wait a minute now. Hold it. That messes up the molecular clock right there. Because if you have more recombination per generation, your population can hold more diversity. You have more pieces of DNA in the population. So how long ago was the Out of Africa event? Well, I don't know. If Africans have more recombination, they're going to look older just because of the amount of recombination.
Right.
And because mutation will destroy the PRDM9 sites over time, much more likely, I forget what the letter combination is, but it's much more likely to destroy it than to create it through a mutation. So our recombination rate should be slowing down over time.
So notice how he perfectly laid it out there, how those sites should be getting destroyed over time through mutation. And it makes a lot more sense. It's much more empirical that those were created. It's much easier to break something, to destroy something, than to build them up. They'd have to provide a series of mutations that could actually build a highly important and functional gene like this specific gene, for example. And it's the same issue when we get into like the orphan genes or the highly functional DNA elements in our genetics. And therefore, recombination rates should be slowing down over time, since more of these are being destroyed through mutations. Let's keep going.
Over time.
So, okay, so that would, and so many good points there that it brings a couple questions to mind. So that would, in effect, I've heard the critics say, okay, the higher levels of genetic diversity found in Africa means Africans are older than non-Africans, but they also look to linkage blocks between Africans and non-Africans, that they look at that and try and say that Africans are an older population as well, and use that to support the out of Africa theory. So that looks like the recombination rates would help with those arguments too, Dr. Carter?
Yeah, plus we don't know how many people went to Africa after the flood. We don't know how many different groups migrated down there. It looks like there was a massive replacement of people in Eurasia. As the farmers learned how to farm in the Middle East, they started spreading out, and they replaced Neanderthals, they replaced the Denisovans, they replaced the ancient hunter-gatherers. Most Europeans in ancient times had dark skin and blue eyes. We see that in all their DNA. And all of a sudden, there's this massive replacement of light-skinned people as they come in with farming. So we can't necessarily look at modern people and say, this is what the original population looked like. Europeans specifically, we're inbred. We're one of the most inbred large populations on the planet. Europeans came from a very small population group that took over a large area. There's not a lot of genetic diversity in Europe compared to specifically Africa or even the Middle East.
So do you guys see why a lot of these critics, like Swamidass, and this isn't to be mean, but this is the problem, okay? As you can see here, he said Europeans are highly, highly inbred. What does inbreeding do? Inbreeding is destructive. Okay, what would this do to the PRMD9 sites? As Lena says in the chat, she says, but the activity of that gene leads to erosion of the sites, and the inbreeding, those reductions in heterozygosity, is detrimental. Those mutations, those deleterious mutations, come to the forefront. They're manifested, leads to genetic erosion. Genetic variety is lost, of course. So, right in this, and the thing is, it's only a 5-minute video, and one of these questions that Swamidass asks is answered directly in the video. And based earlier on what Dr. Carter was saying, Matt and I only had to listen to this answer. Now, I've always understood that recombination was not random. I've said in debates for the last couple of years that they assume constant rates of gene conversion, recombination. Okay, they don't take into account different mutational events for different populations, like in Africans, for example, different histories. Africa is closest to the equator, which can be detrimental. But yeah, we're going to get into that after. But, that's the thing. We understood it right off the bat. We understood what it meant. We understood the implications. Let's keep going.
Yeah, I saw one of the papers that was recently written. They discovered what.
Let's listen to the European inbreeding one more time, just to get it through their head. That's important.
It's a replacement of people in Eurasia. As the farmers learned how to farm in the Middle East, they started spreading out, and they replaced the Neanderthals, they replaced the Denisovans, they replaced the ancient hunter-gatherers. Most Europeans in ancient times had dark skin and blue eyes. We see that in all their DNA. And all of a sudden, there's this massive replacement of light-skinned people as they come in with farming. So we can't necessarily look at modern people and say, this is what the original population looked like. Europeans specifically, we're inbred. We're one of the most inbred large populations on the planet.
We're one of the most inbred large populations on the planet. We're inbred. We've got lower genetic diversity than the Africans. The Africans have more of these sites, okay, these PRDM9 sites, and more recombinational hotspots. But we're going to get this is kind of just an introduction, but you can just see so much amazing information in just, a few minutes worth of explanation. So all that inbreeding would erode those sites. There'd also be fewer recombinational hotspots, less diversity. And what Dr. Carter is saying here is backed up by science. This isn't contested. John says, sidebar, we argue over things like recombination sites. How do they explain specific location of promoter sites? Exactly. Don't even get us started on that. How many times have we issued that abiogenesis challenge? Professor Dave attempted. He didn't know he was taking the challenge, but we brought Dr. Rob Stadler on and had some fun with that. So they don't want to answer those tough questions, of course. I doubt anyone else is going to take that challenge. And hopefully Professor Dave responds. We'll have Dr. Stadler on again to refute the response. So let's keep going.
Europeans came from a very small population group that took over a large area. There's not a lot of genetic diversity in Europe compared to specifically Africa or even the Middle East.
Not a lot of diversity in Europe as compared to Africa or even the Middle East, like he said.
Yeah, I saw one of the papers that was recently written. They discovered what they call cheddar man, and he had black skin, blue eyes.
Well, when those letters appear in modern people, they're associated with darker skin tones.
Mm.
But it's not perfect. 23andme.com says I'm supposed to have blue eyes. I don't have blue eyes, but I carry a variant that's very strongly associated with blue eyes. So the inference of how a person looked from their genetics is imprecise. And even if it works in a modern context, we don't know the ancient persons, all these other variants.
Okay, let's go to, there was one here that I pulled up nicely. All these papers, awesome, must read. I got to get to, so here's a good one. The landscape of recombination in African Americans. Recombination together with mutation is the ultimate source of genetic variation in populations. Remember, they explained the origin of all DNA differences, all genetic diversity as a result of genetic mistakes over time, typographical errors. We look to the design diversity hypothesis, and everything flows nicely from there. The numbers are there. The numbers work out. So right over here, it says... at intervals of more than 3 megabases, it is nearly identical to at finer scales, it differs significantly, and we identify about 2,500 recombination hotspots that are active in people of West African ancestry, but nearly inactive in Europeans. Up here, I shouldn't have skipped this part. So we leverage the recent mixture of people of African and European ancestry in the Americas to build a genetic map measuring the probability of crossing over at each position in the genome based on about 2.1 million crossovers in 30,000 unrelated African Americans. Down here, talks about the PRDM9 gene. In humans and many other species, recombination is not evenly distributed across the genome, but occurs in hotspots. And you can go over how the African Americans, the Africans have more. Let's see another one of these. I wouldn't want to bore the audience and read through these entire things, but definitely check them out if you're interested. You know, these are based on empirical facts. Let's see here. PRDM9 variation strongly influences recombination hotspot activity and meiotic instability in humans. PRDM9 has recently been identified as a likely transregulator of meiotic recombination hotspots in humans and mice. There was one, let's see if this is the one I'm thinking of. We'll go to, there's one where you're going to see some good stuff on the recombinational hotspots themselves. Maybe it's this one. There's a lot of papers on this. Maybe it's in this one. PRDM9 controls activation of mammalian recombination hotspots. Mammalian meiotic recombination, which preferentially occurs at specialized sites called hotspots, ensures the orderly segregation of meiotic chromosomes and creates genetic variation among offspring. Before I shut down and get to the bulk of this, there is one thing I want to show you guys, but like I said, there's a number of papers here, and bear with me. We'll find it. We'll find it. I'm going to put all these papers in the description box for anybody that wants to read over them. Here we go. Right here. Recombination hotspots, where historical crossing over events are clustered and separate relatively large haploblocks, have been a topic of considerable interest in the scientific literature. Right over here. Several recent studies have observed that the locations of most hotspots tend to be shared between diverse populations. However, several data sets have suggested that some hotspots may be population specific, and that, so pay close attention to this, and that African and African American populations have more recombination hotspots relative to non-Africans, given that recombination rates vary between species. Now, this is an article that I highly recommend reading. This is by Dr. Rob Carter. So he's been talking about this this is an article I've had for at least a year printed off, the neutral model of evolution in recent African origins. And he talks about this very thing in it, where he goes into gene conversion, recombination rates, recombination not being so random, and the evolutionists assuming a lot of things where in their very own literature has been questioned. That even goes for coalescence and random mating, for example, which we talked about before. So definitely check those out. But let's get into the bulk of this. Okay, let's destroy this argument here. Okay, so regarding the PRDM9, it is well known, okay, that this regulates, controls, and influences recombination through recombinational hotspots. Okay, so guess what? If this PRDM9 gene is not functioning properly from, say, mutations, okay, that are occurring from generation to generation, that it seems pretty obvious, you'd think, that recombination is what? As Lena said in the chat, it would be hindered. You know, the erosion of these sites would not be good. Look at yourself, these statements taken directly from, I believe, Trends in Genetics. Here, I'm going to try and flash them on the screen for you guys, get you some visuals to look at. So let's see. Tell me if you can see that. Studies of highly diverged species have revealed two mechanisms by which meiotic recombination is directed to the genome through PRDM9 binding or by targeting promoter-like features. And this one right here. PRDM9 influences the possibility of genetic exchange by determining the locations of meiotic recombination hotspots in most mammals. So can you imagine over time the erosion of those, or the European populations being highly, highly inbred with less genetic diversity than the Africans? You know, what is the obvious result of that? So I'll leave that on the screen for you guys to read as I go over this. So let's think about this logically, okay? It should be obvious that the more broken or lost the PRDM9 is, the less enzymes there are to bind to different recombination hotspots, okay? This provides what? Well, of course, it would provide less overall recombination as time goes on. Therefore, it should be logical and obvious that going back in time to, say, points where we have more and more fully functioning and fully working PRDM9 genes, that would be points in time where we have more recombination. More recombination would be occurring, essentially. The more recombination events we have, and the more effective recombination would have been in the past. This is why in Africa, where people clearly have more PRDM9 genes and more recombinational hotspots, we see more rounds of recombination and a more what? Shuffled genome. That doesn't mean they're older. More diversity, okay, does not necessarily mean an older population. So in a nutshell, and Lena Powell says binding sites get destroyed by mutations. Okay, so let's see. In a nutshell, if Africans have more recombination hotspots and the PRDM9 gene helps initiate recombinational hotspots, then logically that would mean Africans would have more recombinational events. This does not mean they are an older population, as I said, okay? Evolutionists seem to assume, like I said earlier, constancy in terms of what? Gene conversion, recombination, mutational events. Now, the critics, like Evograd said, you know, we've understood that recombination was not so random, and I understand that. But the problem is they'll use these arguments, yet knowing they're not as disastrous to biblical creation as they want to make it out to sound like. Because if they are aware of these answers, like, for example, the created heterozygosity that Swamidass pretends to assume, but then uses an argument that would assume that God would not have created these design-created variants within useful linkage groups, you know, prepared and ready for adaptive purposes, for variation from generation to generation. You know, did God front-load Adam and Eve and the created kinds with this functional genetic diversity, internal genetic diversity that natural selection can use for adaptive purposes, for variation from generation to generation? And then he realized that, oops, you know, I forgot to put these in functional linkage groups. So, you know, so clearly it's not assuming the same created heterozygosity hypothesis that we would assume. So here's the thing. As I said, this doesn't mean older populations. Okay, they're assuming constant rates in the gene conversion, population histories as well, differences in selective and environmental pressures, demographics, you know, all of these things need to be considered. African populations, for example, have had totally different histories. According to our model, totally different histories post-Babel than non-Africans. The people moving into Africa versus the people moving into Europe, you've seen Dr. Carter talk about how Europeans are the most highly inbred large population there is. There'd be totally different histories, totally different mutational events, we'd have different instances of inbreeding. Look what happened to the Neanderthals, for example. And then intermarrying and inbreeding would be different among these different subpopulations as well. It's not just a one-size-fits-all type thing is the point. Now, we need to consider these things, and when we do, we realize that the data best fits an out-of-Middle East event. Now, back to recombination rates and recombination events, okay? If non-Africans have fewer of these sites, as we all seem to agree on, this is what the evidence seems to suggest, then we should expect evidence for fewer recombination events. There are many reasons why Africans may appear, okay, quote unquote, older. But this is all based on evolutionary assumptions, presuppositions, their worldview. It doesn't consider the factors that I just mentioned above. Let's think about this, okay? The population at creation and in the pre-flood world would have then logically had more functioning, based on everything I've been saying, based on what Dr. Carter was saying, they'd have more functioning PRDM9 genes, okay, that work to produce more recombination events, leading to more scrambling and diversity. But more population history, different population histories, different environmental conditions, different mutational events, as I mentioned above, has led to Africans retaining more of the original PRDM9 genes, while non-Africans have lost many that they had from the original diversity. They have lost many, given that they have overall less diversity today. Europeans seem to have interbred and intermarried. Now, I want to focus on the Tower of Babel, for example, okay? Let's say, Super Whore Energy in the chat, good to see ya. Said something about the way I say meiosis. Hey, don't be making fun of us Canadians. I know we got that funny accent. Okay, so let's focus on the Tower of Babel. So let's say we had a number somewhere in the thousands for Babel, okay? Given what we know about population growth and how many years Babel was since the flood, okay? Babel occurred, according to scripture, probably a few hundred years after the flood. So we've got thousands, maybe a couple thousand, okay? All in one place. And they're then suddenly confused and forced to migrate where? All over the planet from one central location in the Middle East at Babel. Each group of people then migrating will have a very good selection of the genes available, okay? Because this group at that specific location would be intermarrying, okay? Exchanging genes, for example. Now, these people migrating, then they're going to have a decent selection of genes available in the Babel gene pool or population. Doki Doki, thank you for the super chat. Doki Doki singing. You don't want to hear me sing. Okay, so here's the thing. This is actually why, this is fascinating. This is why we don't find a heck of a lot of genetic differences between people groups or so-called races around the world. You know, there's no such thing as races. We're all one race. That's what the Bible predicted. That's what genetics confirms. We're all incredibly similar. The evolutionists didn't predict this. They didn't. Now, this speaks of the Babel event. We have so much commonality. It's actually amazing. That's why I said it's fascinating. People groups across the planet are 99.9% similar to each other. Me and Stupid Whore Energy and Jason and John in the chat, we're 99.999% similar, okay? Even given how different we may look. Now, here's the thing. We're only separated by really just a few mutations that would have occurred post-Babel since the dispersion. Okay, actually, I like how Dr. Carter, I'll show a video here in a second. I like how Dr. Carter explains how God divided the nations according to Y chromosome. And this is why we've got Y chromosomes that are geographically specific. We've got traces of the Babel event in our genome. Doki Doki says, sing stream at 10,000 subscribers. Yes. We get 10,000. I'll get John in here and we'll both sing. Okay, so as I was saying, you know, we've got African Y chromosomes, we've got European Y chromosomes, Chinese Y chromosomes. This is all indication of mutations post-Babel that have occurred in different people groups, obviously, if they're geographically isolated and specific. Also, the fact that the evolutionists can't explain team dodgeball, dodge, duck, dip, dive, and dodge, the 5 Ds of dodgeball. This is why they're taking weeks and weeks to respond to the genetic data that they think is so easily refutable. You got Dr. Dan who says, well, I've never seen a good argument because one of his evolutionist supporters said, you know, that they need to do a better job against our arguments and with our arguments and dealing with us because we have good arguments. But Dr. Dan said, I've never seen one, but yet they take weeks and weeks to come up with a rebuttal to that which apparently is not good evidence. It's a psychological game we're not going to fall for. So here's the thing. The Y chromosome is incredibly similar worldwide. Every single Y chromosome on this planet is nearly identical, and you can trace them back to one ancestor just a few thousand years ago. Okay? It's only about 4,500 years worth of mutations in our Y chromosome. Now, here's the thing. We've got very little variation, but guess what? The Y chromosome appears to mutate fast. Look how different the human Y, okay? Jason says 99.988% similar. Exactly. This is why they invented the post hoc ad hoc out of Africa, population bottleneck that would have been incredibly detrimental to the genome. And we touched on that in great detail in our last video, so definitely check on that. So look how different human Ys are from chimpanzee Ys. I mean, if you consider overall architecture, gene content, it's like less than 35% dissimilar. And yet human Ys are all so incredibly similar. Meaning, pay attention to this. This is actually a fatal blow to the evolution story. What this means is the only way, let me ask any evolutionists in the chat, what is the only way to keep a Y chromosome so similar even though it is rapidly changing? We'll see if we get an answer. I'll give you the answer. The only way is for it to be young. Okay? Every single Y chromosome on this planet, think about it, is incredibly similar. It's identical. Yet we know the Y chromosome mutates fast. It's rapidly changing. You know, they've got many different explanations for why it may be so dissimilar to the chimpanzees. They'll oftentimes say the chimpanzee is the odd man out, okay? But here's the thing. For it to still be so similar, even in light of the crazy things the Y chromosome does, means that we are young. The Y chromosome is young. There's no highly divergent and highly mutated Y chromosomes in some subpopulations on the planet. No, we don't find it. You know, answer this question, evolutionists. How do we keep the Y chromosome so similar, even though it's rapidly changing? There's only one conclusion. This speaks to a recent common ancestor. It speaks to who? Y chromosome Noah. So I'm going to play a clip actually, because I like the way Dr. Carter explains some of this. But also, because I'm going back to Swamidass's question that I had on the screen, okay? And it's just so funny how it's answered right in the 5-minute clip. And this is what this is. They don't read the literature. They don't read the technical papers. They don't watch the lectures. And this is why, for the most part, it's just ad nauseum dealing with them in blogs, for example. I prefer discussions. I prefer live discussions, debates, not endlessly in blogs answering the same questions. So, but here's the thing. The enzymes required to bind at particular placements, okay, are made from the gene PRDM9. They're going to have high potential for being degraded through inbreeding. Inbreeding is disastrous in populations, as we know. It stands to reason then, okay, to answer his question that Dr. Carter answered right in the video, it stands to reason that since Europeans are more inbred, okay, Dr. Swamidass, Europeans are more inbred than any other line coming from Noah, then it obviously makes sense that we'd be seeing less recombination, less diversity, less recombinational hotspots. And take this, it's just like with genetic entropy. We accumulate 100 new mutations per person per generation. What we now know about genome functionality, most of those being deleterious. Take this point of most accumulating deleterious mutations, this point of increasing mutational load, take it back to a point in time of least mutation accumulation, least deleterious mutation accumulation, least mutational load. That would be a point of perfection. That would be a point of Adam and Eve and Adam and Eve's kids, where they had no mutations. And I love how they say, Adam and Eve, there would have been a significant inbreeding problem. Inbreeding reveals the hidden reservoir of genetic mistakes. If there's no genetic mistakes after creation, there's not going to be any deleterious effects from genetic mistakes that aren't even there. And this same thing goes for the PRDM9 gene that are being eroded over time, that are being broken down through mutations. Take this back to a point in time where you had fully functioning, fully working PRDM9 genes, more recombinational hotspots. Okay, because since Babel, guess what? There's been dispersal, there's been migration. Now we're looking at different populations. They would have taken different genes with them, of course. And in Africa, we see that there's been totally different mutational events, histories. But yeah, let's get into this video that I think you guys are going to like. But I want to get this off the screen. Everybody's good in the chat. Doki Doki says storyboard is the answer. Yeah. So SWE. So is your answer to how we can keep the Y chromosome so similar? Every single Y chromosome so similar. And yet, given how fast it mutates, how rapidly changing it is, would your answer to that be selective sweep? I guess you can say yes or no if you want. But as we're going to this video, guys, because I want you to watch a little bit of what Dr. Carter says here. Make sure you can see. Boom. This is good.
Really interesting. It says, these were the families of the sons of Noah, according to their generations, in their nations, and from these the nations were divided on earth after the flood. Well, this
important question though for SWE. Did the evolutionists, did the community, did they predict such low variation in the Y chromosome, such low variation in the mitochondrial DNA? Did they predict such low genetic diversity? Did they predict any of this before the out of Africa population bottleneck? And answer correctly, because guess what? These are all things that the Bible predicted. And people say, oh, it's a retrodiction. But guess what? Just reading the Bible and the account of human origins in Genesis, these things had to be true. God says he created two people, Adam and Eve. That would restrict genetic diversity. According to evolution, we've been evolving for millions and millions of years, from the Australopithecines to Habilis to Erectus. Erectus was on the planet for millions and millions of years. And guess what would have been occurring during these millions and millions of years? They would have been generating more and more genetic diversity through mutations. Mutations, by definition, add something that wasn't previous there. It adds genetic diversity. So there's every reason to believe that according to deep time evolution, the ape to man evolution story, we would have had high diversity. Look at the chimpanzees, how high their diversity is. They're like 2 or 3, maybe 4 times more diverse than humans. So they didn't predict this. That's the thing. Comes down to testable and falsifiable predictions. So SWE says she doesn't know, and that's fine. And the answer to the question is no, it wasn't predicted. It wasn't predicted. And here's what's funny too about the out of Africa population bottleneck that they resorted to, because they had to say, oh, look, at human beings have such low genetic diversity. And the out of Africa theory, so what they postulated was a population bottleneck that reduced the human population to a very tiny population of about, you get different numbers thrown at you, but it seems like most people would agree that it was 10,000 people. And then the number for how many years is tough too, because there's no record of this in the geological column, right? They're just looking at the genetics and they need to explain why humans have such low genetic diversity. So they might say 10,000 or 100,000 years, but it had to have been many, many generations to decrease genetic diversity. Now we can look today at cheetahs. They're down to 7,000. And look how disastrous it's been to them. They're like identical twins. Their sperm is degenerate. conservationists are worried that they're going to go extinct because of all these deleterious mutations are coming to the forefront. You know, that's what happens with inbreeding. You got all these deleterious mutations that are in recessive form, and boom, they're manifested. Birth defects in cheetahs are crazy right now. It's sad, you know, they're on their way to extinction. But guess what? According to this model, okay, they didn't predict it. This model didn't come out before. Think about it. Apparently, we went from Homo erectus, boom, to Homo sapiens during this disastrous population bottleneck that should have driven us to extinction. It didn't occur for 1 generation, 2 generations. I mean, we're talking like 1,000 to 10,000 to maybe 100,000 years. I mean, that is disastrous to a population. Should have driven us to extinction. And yet all living human beings today originated from what? This very small and very highly inbred population. So we went from Homo erectus, who the evolutionists say was pre-human, primitive, you know, and then we had this boom, disastrous population bottleneck that should have driven us to extinction. And out came modern man that suddenly exploded in all parts of the world, seizing dominion over the planet. And now look at us. We're building airplanes. We're building skyscrapers. I'm sitting here on a laptop that humans have designed and built. You know, it's evolutionary storyboards. It's post hoc ad hoc. It wasn't predicted. The data, the funny thing is, the more that you read about, like, they're contesting each other with the multi-regional hypothesis, the out of Africa, the recent out of Africa hypothesis, it's getting closer and closer and closer to the biblical model of the out of Middle East model. So anyways, guys, listen to this. SWE likes to take me on rabbit trails, but I like it. I can talk a lot. So, well, Lena makes another good point. How would some process like evolution create something like the PRMD9 gene? This is impossible. Exactly. Great point. And that's why I always ask, you know, what type of mechanism, evolutionary mechanisms, can evolve that which requires forward thinking? Recombination is amazing. It's an amazing design feature. Leads to variation from generation to generation, okay? And yet evolution through forethinking, evolutionists now, they need to give these evolutionary mechanisms a mind with what we know about redundancy, redundant elements, this PRMD9 gene, and epigenetics, for example. You know, they're giving evolutionary mechanisms a mind, when in fact, forward-thinking mechanisms require a forward thinker. You know, the God of the Bible through his foreknowledge. And it's just like Lena said, just like Dr. Carter said, this PRMD9 gene, highly essential, highly functional, obviously, highly important. What series of mutations can you show me in the lab that's empirical that can build such a highly essential gene? No, it makes more sense, like Dr. Carter said, that they would be destroyed over time through mutation. It's much easier to destroy something than to build something. How many mutations, what series of beneficial mutations would you need to show us that can build something like a PRMD9 gene? You know, it's not going to happen. It's storyboard.
This isn't a thing called the Table of Nations. It's just a list of all the sons of Noah and their sons and a few of their sons and where they went in the world. What this is saying is that God divided the world not according to language, but that he used language to divide the world according to Y chromosome. And he took the clans, which are paternal based on Y chromosome, and sent each one in a different direction.
And it goes back to the 3 sons of Noah.
Goes back to the 3 sons of Noah. Well, this is actually the key to understanding modern genetics.
Okay.
Because modern genetics has raised a couple of puzzles, but they're explained by the Genesis account. For instance, we've already discussed how there's very little variation amongst Y chromosomes. But it turns out that the variations that we do find are very specific to geography. Like there are Irish Y chromosomes, African Y chromosomes, Chinese Y chromosomes, Pacific.
One thing that comes to mind as he's saying this, and I covered this earlier, and I like the way he puts it, is how many religious texts that have to do with human origins. You know, we got the Bible that talks about how God created de novo Adam and Eve, okay? And then we had the flood bottleneck, 8 people, okay? And we see those 3 major mitochondrial DNA lines, perfectly consistent. Oh, what a coincidence that the Bible tells us that the 3 reproducing couples after the flood were Noah's sons and their 3 wives, Noah's 3 daughters-in-law. And yet we see 3 main mitochondrial DNA lines, the 3 major haplogroups. And then the Bible talks about the outer Middle East event or the outer Babel event. And yet we see it all in our genetics. We see it all so consistent. Is this all just a coincidence? How many other religious texts are so consistent with their version of origins and also the scientific data? None. None of them out there are so consistent.
Islander Y chromosomes. These are very similar Y chromosomes, but since the people have gotten to where they are, mutations have occurred, mistakes in the spelling of the books of the genome, and each one is stuck in a specific location. But the mitochondrial DNA, because God sorted the world according to Y chromosome and not the female line, the mitochondrial DNA all spread out. And that's why we find all 3 of the mitochondrial lines on all 3 of the continents. This is an incredible prediction.
That's amazing.
It is
Absolutely
amazing.
fascinating.
And after all that, after all those 3 big topics, I'm forced to conclude that modern genetics has essentially rediscovered.
Right, look at this. Modern genetics. That which is direct, that which is inherited in sperm and egg, not a rock, not a bone, not geography like they want to look to. The low quality science. Look at modern genetics has discovered, it's validated the big picture of origins. That is for certain. Number 2, discovered the creation, the flood, and the Tower of Babel. And number 3, no obvious disproof, much support. That's right. There's been no, I mean, this is the best they got, this whole recombination so-called issue. Recombination rates are too slow. Generating diversity would be too hard. All of these so-called objections that they think are the best and coming from the best, essentially. And they're failing so easily, as you can see here. So what does that say? As biblical creationists, do we need to tap out and say, yep, out of Africa is true, evolution's true, pine trees and whales are related through common ancestry? No, there's been no real disproof. Now, can we know, do we have an answer to everything? No, nobody does, not even the evolutionists. There's always going to be unanswered questions, especially when we're dealing with things in the past. But the point is, the data is so consistent. And the more we study, we're in 2020. The more we study, the more we learn, the more consistent it becomes. That's why creation scientists now are even able to make testable predictions that lead to active research programs that the evolutionists don't want to deal with.
Genesis. Just the big picture of Genesis. And that's all you can expect because it was thousands of years ago. We can't get exactly all the nitty-gritty details. But
there you go. I didn't even know what he's going to say. Exactly. The big picture is what we got. Happened so long ago, like Dr. Carter said. Are we going to get all the nitty-gritty little minutia? No, but I guarantee, given how consistent the data is with our position, that's what the critics, who have their basic presupposition that apes and man are related through common ancestry and the Bible's account of human origins is false. This is their starting point. They have a different worldview, different presuppositions and assumptions going into it. So no, they'll point at a little minutia, a little detail that may be a little more difficult to answer, ignoring the bigger picture, ignoring the questions and challenges to their model.
From 10,000-foot view, when we look down at the data, we say, man, there's a lot of data that supports the biblical account, including the creation, the flood, and the Tower of Babel. Now, as a scientist, I'm really skeptical. I don't believe science can actually prove much of anything. I believe we can disprove things. And I don't find any obvious disproof for Genesis in modern genetics, and a lot of information does support it.
So if we said creation's true, the flood's true, and the Tower of Babel's true, what would we expect genetically to line up with that? It all lines up.
Yes.
Okay, that's amazing. God knew about genetics long before we did. And his word proved.
So that's a good video I wanted you to see. Let me see what else I had up here that so we dealt with the recombination rates. We've gone over these a number of papers that definitely have a look at some really fascinating data, perfectly consistent with our model. So here, the first couple, Adam and Eve. Okay, so I deal with it here, especially with Africa. I say, and you can follow along here. This is just a PDF. You can also get the Kindle version, actually. So I point out evolutionists assume that the more mutations and diversity in Africans is because they are an old population, just like we covered. They think this demonstrates a deep time history that goes well beyond 6,000 years. Experts in evolution have inferred that Africa is the most likely originator of mitochondrial diversity in the world. Regarding mitochondrial DNA, Africa has a much larger branch than non-African branches. A major assumption made by proponents of evolution has to do with population history, as we talked about earlier. And here are some of the assumptions. This would include generation times, as well as the number of children various populations were having. They also assume away hypermutating lineages. They rarely, obviously they're aware of it, but they don't really talk about the recombinational hotspots that are in an abundance in Africans. Not to mention the gene that assists in that. For example, if a mutation affects the workings of the DNA repair enzymes, more mutations will accumulate. This would lead to divergence in population genetic differences. All these assumptions have been questioned. This is important. All of these assumptions have been questioned, okay, in their own literature. Therefore, the better model is the out of Middle East model. Also consider inbreeding. Inbreeding is bad because you get what? A rapid fixation of harmful mutations. What does this mean for Africa? What does this mean for Neanderthals, for example? Well, we know that African populations were divided into small groups of people that remained small and separated for long periods of time. Under these conditions, it would be expected that those small tribes would diverge rapidly. The more fixated mutations, the more the populations would diverge. This can explain why Africa has the most genetic diversity. See how more diversity, okay, or the appearance of more shuffling, more recombinational events, doesn't necessarily mean that it's an older population. Because we have to consider different mutational events, different histories, different selective pressures, different environmental factors. They know this stuff exists. They just want the knockout punch, and they don't want to focus on these fascinating details. Africa has more genetic diversity than let's go up here, than the rest of the world combined. Two people living in different cultural groups within Africa itself can have more differences than a European and somebody from China. The assumption the evolutionists have made about population histories has been invalidated. As we go away from the Middle East and any country in the world, genetic diversity decreases. This is because fewer and fewer people made it the further we go around the globe. Some of the most homogeneous populations in the world are amongst the Native Americans. This is also true in Africa. If we travel south in Africa and west in Africa, genetic diversity decreases. The hotspot of diversity is where? The hotspot of diversity is right next to where biblical creationists say was the Tower of Babel. See, it's too close for comfort for them, right? They don't want to put it right where we would say our out of Middle East event took place. No, of course not. And we go on here too. There's a paper, the Eve mitochondrial consensus sequence, okay? And I talk about Dr. Carter, Dr. Griswold, and Dr. Sanford make it clear that the empirical data fits with our model. They point out the genetic facts, apart from the formulation of historical scenarios, are clear. A, there was a single dispersal of mankind with 3 main mitochondrial lineages interspersed within the clans. Isn't it funny how consistent that is? This dispersal either passed through or originated within the Middle East. These things happen in the recent past. The dispersion was essentially tribal in nature, with small groups pushing into previously uninhabited territory. In addition, genetic evidence indicates that male lineages are much more geographically specific than female lineages, with female migration rates up to 8-fold higher than males. A direct confirmation of the Babel account, where the initial well-mixed population split up, as we were talking about earlier, and migrated according to paternal lineage. These facts are very consistent with a biblical scenario. And then we go into the Neanderthal, which is a similar situation. So as you can see here, you know, that, I mean, we've gone over an hour just on that one issue, mainly talking about the entire time that specific gene and recombination. I mean, the evidence is overwhelming. That's why we can easily go for 2-3 hours a night, because there's just so much supporting the biblical creation model. So let's see how everybody's doing in the chat. Doki Doki, thanks for the super sticker. Lena, thanks for your input. You had some great points there. You made the debunking even better. Next week we should have we're just going to be confirming soon an interview with somebody that we're really, really excited to interview as well. If you haven't yet, check out the Dr. Carter, Dr. Stadler, Dr. Jackson interviews. Like right in here, this is a mitochondrial DNA tree. And guess what? Like we talked about yesterday, you notice a pattern, a pattern that's exactly consistent, that's exactly expected from our model, right from a center point, explosive growth. Look at these lines. Look at the difference in these lines in the HVR haplogroup in Europe. A lot of these mutations are sporadic. They're occurring, and the evolutionists want to assume that they can actually date, say, the split, that they have a consistent enough molecular clock where they can say that chimpanzees, because they're using the phylogenetic method. Okay, well, we're using the measured mutation rate. But when you're looking at the haplogroup in Europe, I pointed to this the other day, HVR, notice how the branches there, they got different lengths. So obviously that means that the people there that have a common ancestor, and yet there's one group in there that happened to pick up twice as many mutations as their cousins. Okay, so think about it logically. If we're picking up more mutations in the same amount of time, this means we can't just look between humans and chimpanzees like they want to do and then make some kind of assumption or a series of assumptions about when they split. Right now they're saying about 6 million years ago. No, this is random mutations occurring in populations over periods of time. And guess what? It's the pattern that fits our data. There's not a lot of mutations there in mitochondrial DNA based on the measurable mutation rate. Mutates fast, okay? So what we see here is, here's the thing, Evograd, they will look to coalescence theory. And I talked about it yesterday because I was debunking speed of sound and also debunking godless engineer. But Evograd's using more or less the same argument. And they're assuming that given enough generations, you can see it in one of his other comments, okay, that, what we see is expected from the evolution side. And they're saying that given enough time, given enough generations in people, you're going to reach a point where you can trace back to just 2 common ancestors. But I like the way Dr. Sanford points out the fact that this coalescence theory was brought in to explain the data because it has inbuilt assumptions. One of the assumptions being what? Talked about it yesterday or maybe 2 days ago. Random mating, okay, where you got a population where all the people in that population have a strong chance or likelihood of say marrying or mating. But that's not true historically. That's an invalid assumption. Humans have existed in tribes, and those tribes have been separated. There's not random mating. So that's the whole point. We can touch on this all day. I wanted to keep it just on the recombination rates. But I wanted to kind of touch this part at the end because I noticed Evograd did use that argument. So I think we're kind of going to cap it just at an hour here. But like I said, we still got a lot of good interviews, discussions, lots of stuff to look forward to. So guys, thanks for sticking it out. I hope everybody had fun in the chat. Doki Doki, always a pleasure. Lena, this boy draws, faithful, honest, and true. So yeah, thanks for joining, guys. God bless. This has been fun. And just goes to show that even their best arguments that they can come up with, they're just not doing it. Thank you, SWE. Good night to you as well. Thanks for joining. It's been fun. It was a bit late, but I hope it was worth it. So we're going to shut her down for the night. God bless everybody. Good to see everybody. Standing for Truth is out.
For all those who appreciate the work that we're doing here on Standing for Truth,